Next up is a short panel discussion, which I'll moderate and where we discuss the technological and organizational side of machine learning with some of our speakers. Let's welcome our panelists. First, we have Dr. Stephen Galsworthy, Chief Data and Product Strategy Officer at QB. Next, we have Sonia Waxmonsky, Senior Data Scientist at Blue Cross Blue Shield of Illinois. And finally, we have Yonggang Cao, Principal Machine Learning Engineer at Outreach.io. So let's jump into the first question here, which is, I think I enjoyed all of your presentations, but I'm not sure if everyone listening into this panel actually saw every single talk. So let's start off this panel by having each of you, starting with Yonggang and then Sonia and then Stephen, give a brief summary of what you discussed in your presentation.
Sure. I'm Yonggang from Outreach. Basically, our presentation is about continuous integration and continuous delivery for the ML model and service. So basically, the goal of our work is just like any typical CI/CD, we want to guard people from making breaking changes, and we want to guard the bad model from being released. So we want to automate all those steps in the cycle. Once people check in, we want to guard the quality of each change. Once we want to deploy a new model, we want to guard the model with quality assurance and latency assurance. And we also want to have those backup plan like a rollback. If we found some model, maybe in biometrics wise, it looks as good, but it may have some edge cases which could be very annoying to the customers. We want to have ability to roll back. So just by one-click rollback. So that's basically our focus for our work, definitely. And there are some challenges because we use all kinds of tools. We need to align with the company-wide tool sites. So we use both Databricks and Circus AI and Concurs. We want to integrate all those tools to work for our purpose. So yeah, there are many learning and struggling on the way. So we want to share our experience on this journey. So that's pretty much about our talk and our learning for sharing.
And Sonia?
Yeah, thank you. So myself and my co-presenter, Derek Higgins, are from Blue Cross Blue Shield of Illinois. And we both have a history and a professional background working in very large corporations and large traditional corporations. I have a background in the insurance industry. And our talk was really focusing on common pain points that we've experienced in a data science project lifecycle that tend to repeat themselves across the companies that we've worked at. What a lot of the pain that comes from is, working at large corporations that we're dealing with disparate teams that have to come together to make something happen. Teams working in different technologies have different traditions of how they store code and work on a project. A lot of times we're working with teams who aren't necessarily have data science as their core competency. And the focus of our talk was talking about kind of what are the common pain points that we see and what are solutions that we find. And a lot of it often does come down to centralizing code and data. A lot of organization problems can be fixed really or mitigated by bringing just the data and the digital information together in one place. So our talk is about how that can be done in terms of organizing code, how it can be mitigated in terms of storing data, and what tools like Databricks are available to help with these pain points.
And Stephen?
Yeah, me and my colleague Ernie from a company called QB. We're a tech company based in Amsterdam, and we're dealing with large amounts of IoT data. So we're dealing with petabytes of IoT data that we collect from a number of different sources, such as smart meters and thermostats installed in Europe. The talk that me and my colleague gave was to give a little bit of a focus on how some technologies can be applied to simplify different aspects of the model developments and management cycle. Firstly, choosing the right model, how to do that, what tools are available, finding the latest model. So moving from a scenario where These models can just be asking a colleague of which is the latest model available, and then moving into what tools are available for deploying those models to production and managing them within a production environment.
So one of the great things about this particular virtual summit is the three of you come from very different companies and industries. And actually, I'm looking forward to each of you answering this question, because I think you might have very different answers and perspectives. So the question is, in terms of your teams, what job roles in data science or machine learning projects are critical in your organization, or the way you think about these projects? So how would you staff your team? So Yonggang, you can go first.
Sure. So in Outreach, different organizations have different roles. For data science org, which I'm in, we actually have a very typical setting. We have a data scientist, and we have machine learning engineers, and we have engineers. So we work together. Actually, we incorporate every role into pretty much every single project, because a data scientist pretty much will do those investigation and experimental work, and machine learning engineer will work with data scientists to productionize those ideas and make sure the system is production ready. And the engineer actually will be participating the production readiness and also participating in the final operations, the monitoring metrics and on-call things like that. So, and also UI is totally on the side of engineer and kind of roles. So we have some specialized front-end engineers, which is shared across different projects. So that's pretty much a layout of data science org in Outreach.
And Sonia?
Yeah, I'd say that we have kind of the similar roles. We have a data scientist and data engineers who specialize kind of each within those. Our work will often tend to overlap. Like data scientists and engineers will both often do kind of ETL research. I would say, and we tend to kind of, our data scientists will not necessarily specialize between kind of like machine learning versus kind of generalized modeling. We're kind of ready to go with anything. I'd say one role that I think it exists everywhere, right, is the product manager. But for us, it's become a very important and critical role. And we have product managers on our data science team. So they report into our data science VP. I think in some other organizations, a product manager might be kind of someone who sort of is pulled in more from the business side and who reports into that organization. And we found that it's just really been critical in an organization like ours, just because we have so much data and so many moving parts. It's not necessarily a case where we kind of have a more static, not necessarily static, but we have a more consistent and well-vetted large research database. We are often kind of like collecting data on the fly as the project goes, from who knows what kind of technology. I mean, in the last 5 years, I've had data come from the mainframe that I've had to work with. So we have product managers who will just help with all of those steps. And I often say, we kind of joke in an organization like ours, just navigating the organization is a full-time job, and they help us a lot with that. So I think that's kind of something that might be, more unique to us, but it's proven to be very valuable.
So Stephen, actually, let me, since Sonia gave some interesting points there, let me kind of tweak the question for you into two parts. First is, since you're the Chief Data and Product Strategy Officer at QB, how much machine learning should product managers know these days, number one? And number two, where do you place yourself in the spectrum of centralized versus decentralized data teams?
Very, very good questions. And that's something we've really seen evolve as the maturity of machine learning QB has changed over time. So when we really started off, we had a number of data science roles that were able to really cover everything to get a proof of concept up and running. And we were lucky enough to be working with product managers at the time that had an intrinsic interest in machine learning and what data science could do. What we've seen over time is that the impact of data science at QB has spread across the organization. So we were initially concentrating on bringing a few products to market with machine learning under the hood. Now I would say over 80% of everything we bring to the market has some form of data science or machine learning in it. So naturally you need to have product managers that are able to think along with that. What we've also found is a role that's just spanning this gap between the business side and the technical side, a role that's sometimes referred to as analytics translator or so. So this is not a formal role as such within QB, but it's often filled by someone coming more maybe from a business analyst background or even a data scientist themselves, who are able to bridge the gap between the business perspective and the data perspective, particularly important when it comes to developing services for end users. You want to ultimately end up with a model that adds value and a service that adds value. You need to approach that both from the data side as well as from the end user perspective. And what we find is those roles meet in the middle. On the other question,
Centralized versus decentralized.
That's also something that has evolved. When we started off data science, when I joined QB 4 years ago, we really kicked off the data science team. What we found then was centralized really made a lot of sense. We really wanted to build upon the strengths of that group and be able to really catapult things and build up momentum. As things have changed over time and data science is spread across the organization, we see that becomes less and less centralized, where data science is happening independently across the organization. But I'd say we're really more in a hybrid model right now. So in QB, the data scientists all ultimately report into me as the chief data officer. But in their day-to-day work, they are working in multidisciplinary teams of 20, 25 people covering all disciplines that are required to get a product out to market.
So the next thing I wanted to ask you guys is, so while the topic of this virtual event was MLOps, as you know, everything actually depends on having good data pipelines. And actually, I'll be interested to also hear what Sonia has to say about this, because in her talk, she talks about preserving some of these artifacts around exploratory data analysis. But let's start with Yonggang. Yonggang, at Outreach, do data scientists write their own data pipelines?
Sort of. So basically, definitely at the prototyping stage, data scientists need to be able to gather data and doing some ETL job through notebooks, and visualize them, and kind of in charge of the whole pipeline to make something demoable. So, but as I mentioned, those kind of ways are not quite production ready. So that at a later stage, the MLE and the engineer will jump in to kind of enhance the pipeline. Yeah, we are not really favorable to use notebook in the production ready pipeline. So we usually will turn them into Python code and have those version control and quality control, like controlled by CI/CD as I was talking about. So yeah, it's kind of in phases.
I see. What about Blue Shield, Blue Cross, Sonia? Because you in your talk, you talked a lot about these artifacts for exploring data that people in your organization, at least, you've gotten to the point where they're expected to document even their data exploration, right? So what about their data pipelines? Yeah. What about their data pipelines?
Yeah, so we definitely do. I'd say that does kind of vary by team, but we are definitely moving towards a model where data scientists are writing their own data pipelines, or at least they're picking up, or the part where they pick up is kind of moving closer and closer to the raw data. So we do have kind of an enterprise-wide analytics database, and so that's generally where we start. Obviously, there's operational databases that feed into that, and a lot of times, like, we're kind of kept out of those for just kind of production load reasons. But generally, kind of when so a lot of times we, as data scientists, we do pick up from that. There are kind of a more traditional model might be, you know, a data scientist or someone working in analytics will work with a data engineering team who might, you know, be in another part of the company and just kind of say, okay, this is what we want. We want you to pull claims for 3 years, and they'll give it to them and they'll roll it all up into one table, and then we start from there. But we're really moving towards more the data scientists taking on that work, and it's definitely kind of the same, the workflow that kind of came up before. We start out working in notebooks, we look in notebooks, we make our decisions in notebooks, and then when it's time to be like, okay, this is what we're going to actually model from, then yeah, we definitely try and move that to Python code. And I also definitely try to push for moving that up front, like even kind of before we even do our modeling, so that we're building models that we can reproduce, we can kind of push a button and retrain the whole thing. And
so Sonia, do you toss the code over the fence to another team?
We have not so far. And I should say, in my career, I have done that. And a lot of times it's kind of, when it's been done, it's more that it's out of necessity. Maybe there's some kind of infrastructure reason that we have to move to a particular language or technology that like the analytics team just doesn't have and doesn't work in or doesn't have access to that plan for. So we've done it for that. We've done over the wall for that reason. But kind of in the last maybe 3 to 5 years, we've moved towards, we don't toss the code over the fence. We build it ourselves. We build our own pipeline. We might transition something if it's something where it's kind of like a big data problem, and just the programming and development skill to really get the runtime down, the performance down is maybe beyond kind of either our skills, or it just takes a lot of time, and we might transition that. More likely, we'll bring a data engineer into our team to help us with that. But I've done things where I had a project maybe 2 years ago where we started up front coding feature vector pools in PySpark. And we did this before we even went to modeling, because we wanted to have that confidence that what we could do, we could reproduce. And it's so that we were not, and I like to say, I've often been the person who inherits code. I've just too many times been the person who inherits the code 2 months later or 2 years later. And I want to make sure that that team has kind of the best product. So for that reason, we take it on ourselves. And it's something, actually, one of the reasons for, kind of for hiring decisions, I really push for data scientists who have strong programming skills, just explicitly so that they contribute to that kind of work, to that kind of ETL pipelining, and do it well. But I find that we have to be involved, because like I said, we have those little data decisions we have to make that data engineers just aren't paying attention to.
Right. So Stephen, this virtual event centered around MLOps. So do you think, given your role, do you think MLOps is a term that's widely known in the C-suites of companies these days, or is it still somewhat of a topic that engineers are talking about, or is it? Do you find yourself, in other words, having to educate people about MLOps?
Certainly. I think MLOps as a concept is not very widely known in the C-suite. To some extent, even the DevOps concept requires a lot of explanation. But I think as soon as you explain what it actually means, it very much resonates. Particularly just the principles of build and run together. That's something that really resonates at the C level. They can understand that it makes sense to have integrated teams that are working together in that way. I would say that the understanding of machine learning as a concept, and I think particularly in the ways that machine learning development differs from traditional software developments, that is still not broadly known across, particularly at the executive level, but I would say in industry more general.
So Yonggang and Sonia, speaking of MLOps, so how would you describe the state of MLOps in your companies, and what changes would you like to see? So starting with Yonggang.
Sure. So MLOps in our company, so the company-wide, not every team is doing ML. So currently, data science org is the focus of doing those ML work. But in general, our company is mature and deliver those kind of non-ML services. So data science team is recently involved making those ML related pipeline in place to make sure we can do those integration tests and weave all those ML related pipeline into the flow of the CI/CD. So that's kind of some recent achievement we made, but definitely we are not completing yet. So for example, yeah, as I mentioned in my presentation, yeah, we are mostly focused on also online serving part and the building model automation, the model building and delivery and things like that. But the offline part is actually a big part. It's kind of missing right now. So we still have those manual experimental environment from notebook to do things like hyperparameter tuning and feature engineering. So yeah, this is kind of our current state of art. Yeah, it's still kind of manual driven. So although we are taking use of MLflow for tracking some of the things, but it's still not fully automated and fully controlled. So that's kind of our future work. We are heading towards that direction. We want to make the annotation and the tuning, the kickoff different runs with different data set with different parameters automated so that we can be more productive. So and we want to involve in the annotation side. We currently use SageMaker grant choose as kind of meet our basic needs, but we still want to have more intelligent annotation pipelines, such as using active learning. We only want to annotate those hard cases instead of waste time to annotate those repetitive, well-known things the model can already do well. So yeah, those parts are the missing pieces we are heading towards to make them better.
So Sonia, is MLOps a thing in Blue Cross Blue Shield?
You know, I would say it's not really a term I hear a lot around Blue Cross Blue Shield. I think that what happens is that, you know, so moving data around and doing analytics and making predictions from data is something that's been a part of healthcare and insurance kind of for decades, right? So it's always kind of been a part of the culture. And it's kind of, I think, a gray area in terms of kind of academically, it's fuzzy. When are you actually moving from kind of traditional analytics into machine learning? And in terms of technology, I think that also we kind of, it's not a switch. I think we tend to move with baby steps, you know, making changes like having the data science teams taking over ETL pipeline. That might happen gradually. Kind of moving into the cloud, changing how we memorialize our data, changing our technologies. These kind of happen in baby steps. They don't necessarily happen at the same time across all teams. So I think it's been a more gradual transition.
So Stephen, a few years ago, one of the big things in our space was data governance. Mm-hmm. And obviously, I think models in some ways are also data. They're functions with parameters that were trained and so on and so forth, but they're also assets. So are you starting to think of model governance as well? So,
yeah, certainly. As it's something we mentioned in our talk, yeah, we see that the source code of a model is not just a code, but it's this combination of the code, the configuration, and the data all together. So as we're developing more and more models and having them in production at QB, then model governance becomes really important.
Yeah, like who can touch that model, permissions, and so on. Right?
Permissions, who can touch it, who is responsible for maintaining that, just who is able to view and find that model. I mean, that's there are a number of tools on the market that make that a lot easier now. MLflow being a good example of that. I think we will see model governance become a lot more mainstream as more and more organizations, particularly ones that are less used to working with data science and machine learning, are building products and services with machine learning at the core.
Yeah, and to some extent, the fact that in many ways the models, particularly in the deep learning world, they're public. It's the data that you use to tune that model that becomes valuable.
Exactly. It's really that combination. It's not just the model code or a particular algorithm that's really the value. It's the entire combination. And I would say, in addition to the just having the data available, it's the way an organization is able to manage the ongoing deployment of those models. So just having the data and the algorithm itself isn't enough. You've got this third component that really comes in, and the skills of the teams involved.
So let's close this by looking a little bit ahead to the future. So, so specifically, I guess present and future. So specifically, two things. So first, what tools or features within tools would you like to have that you don't have right now? And looking ahead, since you folks are developing and training a lot of these models, so what relevant tasks and workflows can be automated? So what parts of a data scientist job do you think will go away in short order? So Yonggang first. So what tools would you like to have? Maybe you can focus on that, and then we can put Sonia on the spot to talk about automation.
Yes. So I already kind of covered a little bit in my previous.
So wait. You have all the tools you like?
No, not yet. So yeah, that's kind of about the future direction. I talked about the future direction, but definitely not all tools are ready. Yeah. So one thing I want to bring out is, we were actually actively discussing the data versioning. So yeah, definitely traditionally, people are already kind of doing data management by using different files with timestamp with some past conventions. But it's not as natural as those code versioning, like Git controlled versioning. So there are some kind of initiative across the web, like DVC and other tools we looked at.
And Delta has version tables, right? So.
Then Data definitely for data warehouse. Definitely Data is a typical solution for that. So it's for large data. So here our data not necessarily kind of from data warehouse, could be from any sources. I think data could be a good solution on that direction. So the kind of different cases in different company for the adoption of the data warehouse. So that's part of the things we are investigating, and also there's kind of automation of the offline process, like hyperparameter tuning framework. There were some tools here and there, but our feeling is that there is no standing out integrated solution around that space about automate the experimenting. So this part we probably still need to do lots of customization and to make it happen.
Yeah, the hyperparameter tuning tool that's somewhat integrated with your model serving environment.
Yeah, with model serving, all those versioning together into a full picture of the ML workflow. So currently, the well-known ML flow, the Cooper flow, kind of bring those tunings piece by piece. But we are still looking into how we can glue all those things together as an integrated solution. And definitely, we wish for there is a strong community about those kind of common goal every company cares. So
Sonia, put you on the spot. So what parts of the data scientist's daily work life will be automated away? Does it include the exploratory data analysis?
No, that will never be automated. That will never, ever be automated. They might become easier. It might become faster. I expect that.
And now there's startups that have, give me your data. I'll go through the correlations and give you what charts you should be displaying, kind of thing, right?
Oh, but that's not even, you know what I mean? Like that's the last mile, right? And I tell you, we deal with just so many things. Like just understanding, especially just working with internal data and working with so many different data sets, just things like, so you'll never be able to automate figuring out what team you have to go to get the data. I will be really impressed if someone can automate our product managers.
That's a data catalog.
Yeah, well, maybe. That's a good point, actually. That's a good point. If culturally we could get everyone to update that consistently and properly. And actually, I have seen some cool tools that kind of will build a data catalog from existing code. And I often say, you know, that's really what I want. When I ask someone questions, really the ultimate answer I want is a link to code where someone has used this field before, so I can answer exactly that. You know, in terms of what else would be automated, we hear a lot about AutoML. I definitely can see that taking off. But at the same time, oftentimes kind of like, doing a grid search or figuring out how to, bin parameters and correlation. A lot of times that's not really our pain point, right? Like that's almost like when we get to that point.
That's icing on the cake.
Like we're having fun by the time we get there. Like by the time we get to that point, we're having a party and we're just relaxing for like a week and like enjoying that part of the data science. I do think that one element I could see kind of being very important is like, along the lines of governance, kind of maybe like feature drift, feature monitoring. That's something that I think it's not, it's intuitive to automate. I think just kind of the understanding of why it should be watched and monitored is something that I think people have to, go through a couple miles and suffer because of it before they kind of realize why this is important to do.
So Stephen, to close, wearing your hat as a chief data and product strategy officer, so organizationally, what should companies start thinking about in terms of machine learning, MLOps, particularly as they ramp up the number of models that they're using? So it's one thing organizationally when you're in the, we have 10 models world, right? So then suddenly you have 100, thousands, right?
Exactly.
So,
yeah. I think it's just access to the data becomes a little bit more democratic across an organization. You need to have both the skills in place to be able to handle that, as well as I would really see in organizations that I've seen are successful in this field, you need to have leadership, and particularly those that are concentrating on the strategic direction of the company, understanding the interplay and what isn't possible with machine learning. That's something that I think is really can make a huge difference. Naturally, I perhaps have a somewhat biased opinion on that approach, but I think what we see is the democratization of data science in general means that everyone from the data analyst through the product manager into even the business developers need to have some awareness of what data science and ML can do. I think we're going to see a lot more roles in the coming years of that particularly sort of senior management level that is going to require as a prerequisite an understanding of data in the same way we've seen the transition in the last 20 years or so of that same level having to understand the tech. So
we've had kind of the chief data officer, and then we started hear rumblings of chief AI officer. So is this something else that you're talking about?
I think you can see parallels with the role of when the chief technology officer came into many companies 20, 25 years ago in many cases. That really that was an initial role of like, hey guys, how do we use tech? Then you've seen the chief data officer largely coming in as, hey, we've got a lot of data, how do we organize this stuff? And then you see more of an evolution of that chief data officer role or the chief AI officer of like, how do we get value from this stuff? How do we embed AI in the core of what we're doing as an organization to really make an impact on all of the other objectives that we have?
And unfortunately, we're out of time. I have a ton of more questions for these interesting folks. And to our viewers out there, I encourage you, if you haven't yet, to watch each of their talks. And with that, thank you.